Hello and welcome to this problem, this difficult looking problem. I want to solve this by factoring. And this, in class we kind of did one with a grouping type factoring. Grouping I don't think is going to work here. I think this is a PQ type of factoring. And that's not easy. How do you do PQ factoring with extra variables? Well, let's give it a try. So the first step in PQ factoring is I want to look at, so I've got a 1 here, that's where my Q comes from, and here's where my P comes from. And I want to look at the possibilities for P over Q. Well, Q is just 1, so I don't even have to worry about the Q so much. But we do get plus or minus anything that goes into A times B. Well, you always get 1, so we definitely get 1 there. You get plus or minus A goes into AB, plus or minus B goes into AB, and AB itself. So basically, these are our possible rational roots. And hopefully one of these works. Okay, how do you figure out, if one of these works or not? Well, that's a good question. Something that would be great if it worked would be 1. That's kind of our favorite value. So let's just try plugging that in and see if that actually works. So I'm going to plug in x equals 1 and see if that works. So if I get 1 cubed plus a minus b minus 1 times 1 squared plus b minus a minus ab times 1 plus AB. So I can't plug in anything for A and B. Those are unknown at this point, but I can plug in for X, just guess, right? So that's what I did. I plugged in 1 here, here, and here. And now I get this kind of long expression, but I think actually this is all going to work out nicely. So 1 cubed is 1. 1 squared is 1, and it's 1 times anything is itself. So this is just a minus b times 1. Same thing here. It's just 1 times something is itself. So it's b minus ab plus ab. And at this point, I have all sorts of things that cancel wonderfully. So notice this one cancels with this one, cancels to 0. This A cancels with this A. Oh, this is wonderful. I love it when things cancel, don't you? B cancels with B, and AB cancels with AB. Everything cancels, and I get 0. Everything cancels to 0 here. So what that tells you is that this x minus 1 thing that we just guessed is actually a root. Now, maybe you plug something in and it doesn't work like this. Maybe you get a bunch of crazy stuff, but in this case, it works. So that's the first part of the PQ method, right? You try to find something that actually is a root. Now that we have a root, we can do some division to figure out what's left over. And let's give synthetic division a try. So I've actually got kind of a second version of this open. So now we know that x equals 1, which is just a guess, actually works. So we're going to do some synthetic division. So we put that kind of in a box here. And then we put all the coefficients. Well, what are the coefficients? Well, it's going to be 1 from right here. And now this thing is the next coefficient. So in parentheses, I'm going to put a minus b minus 1. I'm thinking that it just as like one number, though. So again, I know it's 3 numbers, but think of this as one number. And same thing for the next one. So this next one's going to be b minus ab. And then finally we have ab. So these are the coefficients of my original problem. That's what I put on top of my synthetic division. Then I draw a line. And then we add going down. And then multiply by this going up. So 1 times 1 is just 1. Now we're going to add going down. And this is a little more complicated because we have these extra variables instead of just numbers, but we can still do this, right? This one is going to cancel with this one, and you're just going to be left with A minus B. Okay? Sorry, this is a this is a 1 right here, and we're left with A minus B when we add going down, because again, this one canceled with this one. Okay, so we keep going. We're going to multiply A minus B times 1. Well, that doesn't change. And then we add going down, and look at what happens here. These A's cancel, these B's cancel, and we're left with negative AB. Finally, we once again multiply going up, we'll be left with negative AB. Add going down, those are like terms that cancel to 0. Fantastic. Okay, so here is the result of my synthetic division. I have a 1, an A minus B, and a negative AB. Those are my 3 numbers. So that turns into, as we factor this, well, we have the x minus 1 term from right here. This x equals 1 turns into an x minus 1. And then I'm left with these 3 coefficients. So again, these are coefficients. The 1 is an x squared. This is an A minus B times x. So I'm thinking this again kind of like one number, minus AB. Okay, great. This is going nicely, but we're not done yet because ideally, you want to factor this part of it too, right? You get a quadratic at the end of PQ. You want to keep going. You want to keep factoring. So let me start a new page. Hold on a second. Gotta move this. Let's start a new page with what we have so far. So we have the x minus 1, and then we have the x squared. What was it? Plus A minus B. Minus AB. Okay, so now we want to factor this thing. Okay. Well, how do you factor a normal quadratic? Something like, how does this factor? Well, you ask yourself, 2 numbers that multiply to 3 and add to negative 4. We want 2 numbers that multiply to 3 and add to negative 4. And numbers that multiply to 3 are basically 3 and 1, so you don't got a lot of choice there. And if you make them both negative, they're going to add to negative 4. Well, let's try the same type of thing here. We want 2 values. It might involve variables, but we want 2 values that multiply to negative AB and add to A minus B. So we want 2 numbers that multiply to this. Oh, sorry, I just realized I have a missing x. Let me throw that in, if you don't mind. So there's x there. But anyway, you want 2 numbers that multiply to negative AB and add to A minus B. Okay, what are 2 numbers that do that? Well, the natural thing to do here, I think, the only 2 numbers I can think of that multiply to AB are A and B, right? But AB only would be positive AB. How do you get negative AB? Well, you just make one of them negative, right? You can make a negative A or a negative B. But if you make a negative B, then look at what these add to. A plus negative B does add to A minus B, right? So this works out perfect. So now I can factor it just like I did over here. I can factor this thing right here. So it's going to be x and x, and it's going to be, well, it's those two things that I found, right? The plus a and the minus b. Great, now I've totally factored my problem. The final factorization is x minus 1, x plus a, x minus b. This gives us solutions. Now, if it's just a de facto, this would be how you factor it. This gives us solutions of x equals 1, x equals negative a, x equals b. I don't remember. I don't think I ever said if this is a factor or a solve, but it's one of those. So here are your solutions. Thank you very much.